Hi, this is Robert Hurlbut, and want to welcome you to the Boston.NET Architecture Group. And tonight we have a special guest, Bill Wagner, who's going to be speaking to us on a topic on C Sharp. And this is, of course, something he's been talking about for a long time, and books that he's written and so forth. And really a great pleasure to have Bill join us tonight. This was a talk he was going to give to the Boston Code Camp 36 a few weeks ago in March, and so unfortunately was not able to because of some weather issues at that day. And we really appreciate him speaking to our group tonight. And very much thank you for being here with us, Bill. And I'll turn it over to you. Thank you again.
All right, thank you very much, Robert. And so, as he says, Bill Wagner, I am responsible for all of the docs currently on docs.microsoft.com/.net/C sharp. Okay, and as I said, was going to be at Boston Code Camp, so I'm going to give our sponsors one last shout out. I wish I could have made it, but weather made it not happen. So, with that, the topic I want to be talking about is a concept that we're calling Everday C sharp. And this fits into a couple things that you're going to see happening throughout the .NET product. And, we have a few colloquial names for it in that, .NET was first released, a good 20 years ago. And if you think about it, we don't build the same apps we built 20 years ago. 20 years ago, the web was noticeably slower for a large number of people. We were used to writing desktop applications, so the original ASP.NET Forms was very much a good tool to use inside a corporate firewall where you had a lot of speed and you could send a lot of state down to the browser and back. JavaScript was nowhere near as mature as it is today, including this ecospace with all the libraries. APIs were different. We were talking SOAP rather than REST or JSON, and other things of that nature. So .NET has kept up. So it's now cross-platform. We've got .NET Core. We have all these different kinds of things that we can do. And that has turned it into what we could talk about as an expert-friendly system. If you know the history, you know what tools to pull out of your toolbox. And you know where all the switches are. Whereas if you're new, it's really hard to find those things. And the other problem is there are a really large number of switches and a lot of different ways to maybe approach a problem. So we want to try to put some of those switches, we want to move them so they're not front and center, so you don't have to see them all the time, but yet make sure that people who do need to make some of those modifications can do so. And in terms of the language, there's some things we're trying to really work against in that because of 20 some years of history, there are Stack Overflow answers about how do I do this in C sharp that have got 20 years of upvotes. And it has 20 years of upvotes because it works. And we care a lot about backward compatibility. So it still works. But there's much easier ways to do those things now. So we want to try to really put those front and center. So what do we mean by Everday C sharp? The way I've tried to define this, and here's where I'm still talking to C sharp developers to get a better feel on this, is I'm defining it as the subset of features that almost every C sharp developer uses almost every day. Okay, so that means it's not all new features. It's the intersections of new and old features. But most importantly, they are applicable across any of the workloads and scenarios that you're working on, right? So whether you're doing, a cloud native application, Azure Functions, or a web API, or ASP.NET MVC website, or a Blazor app, or .NET MAUI, or WPF, or whatever. These same techniques are commonplace in all those places. Okay, so that does do a couple different things for you. If you're new to C sharp, it's a subset you should learn first because it's the things you're going to see most often and the things you're going to use most often. And if you've been away from C sharp and you're coming back, it's a good refresher and it will get you immediately doing things that are the most productive way to do it now, rather than the way we did it 5, 10 years ago when you last used the language. And if you've been using it all the way along, it's a good way to see which new features do we think are really, really going to be the things people use every single day. So let's talk about a bit of what that doesn't mean, because we all have natural biases. And especially if you've been using C#. So the first thing is, everyday C# doesn't mean edit all your code now. So an important part of this message is that we on the language design team still take backwards compatibility very, very seriously. So if you wrote something in C# 1.0, it still compiles, it still runs, and it still works. There's nothing in the language that we would go, nope, that's just not going to work anymore because that's just broke. Okay, now you can put an asterisk on that a little bit, because there are some small breaks we do take in just about every single release, because that's the only way we can bring in new syntax. But by and large, everything that used to work or has worked in the past still works. So don't go just say, oh, this is the part we should use now, let's edit everything. Next thing is, it doesn't mean only use the new features, right? C# is a very popular language. It's been popular and remains popular because it's been good since 1.0, right? So, and we've just added to it since then. It also doesn't mean only use the stuff I've used forever, because for any of us that have been used to using C#, we know how to solve problems, and it's really easy to fall into the habit of doing the things we already know, because we're quick, we're productive, we likely don't make mistakes, and it works. But some things that we want to make sure that we do is to fight those biases is, first, older features aren't necessarily easier. So if you've been looking at C# for years, you're going to have a natural bias to go, the syntax I've seen for 5 years is easier than the thing that's new, because you've seen it more often. Okay, so that is one of the things that I do in docs, is that I will often go through samples and we will make a push to put newer syntax in samples as many places as we can, so you see it more often. I'll give you one historical example of that, and then one that we're doing now. Historical example is in C# 6.0, we added string interpolation, where instead of positional interpolation, open brace 0, close brace, open brace 1, close brace, and then positional parameters on a format string or toString, we now said inside those curly braces, just write C# code and put the expression that you want. And we thought, that just reads so much easier. And that old feature came originally from C. It was, even when we did it, that was almost 40, 50 years old. And now this new one, it just reads better. But until you see it, you're going, wait, what are you doing? You're writing C# in the middle of this. And then we later enhanced it. So inside those curly braces for the interpolated C# expression, there can be line breaks and any kind of formatting you want. So now you can read, like, here's a format string and here's text that's a program in the middle of it. And it takes a while to get used to that. But we wanted people to see it and get used to it, because it is a whole lot less error prone. Especially if you have 3 or 4 more expressions, it's like which order is where and where's the parameter matches and so on. So we make all those improvements and we wanted people to see it. And there's a new feature that came in C# 12 that I'll be demoing in a bit, called collection expressions, where something similar is true. We find it to be a much, much better way to say, I've got a collection and I'm going to initialize it or assign it using these elements. And it's a much easier way to do it. So we just want people to see it more. So these newer features aren't necessarily advanced, right? We have this tendency to think of, because I learned it later, since I learned C# 1.0, I learned it later, it's more advanced. So that's the other natural bias we want to kind of slide away from. So since I can't see anybody, I'm going to make 2 calls here. One, I am watching chat, so if you have questions, please pop it in. And if anybody wants to break in an audio and ask any questions before I start on the demo and the code, we can kind of walk through those as well now. Okay. So what kind of things are we really talking about? And what are some of the features that I really want to demonstrate to people that I want them to see more often? So there's a few big rocks that we've added in several of the recent releases. So I'm going to really kind of play in on three of them. So the first one, let me make this noticeably bigger. Sorry about that. I did not go to the big font before I started up Visual Studio. So the biggest one we want to do is collection expressions. Now, if I look at this first one, this is an array of integers, and I can just write it just like that. Square brackets, the elements that I want. Before collection expressions, well, I would have to remember that what that would be is it's curly braces. Okay, and it looks like that. Cool. I also can use the same thing and make it an empty array. So for any collection, if I want the empty collection, I can just put open and close parens, or excuse me, braces, and it's done. Now, so far that's pretty simple. What the compiler is going to generate in each of these instances is it's going to see those expressions and say, okay, I know I'm assigning it to an array, so it will create an array and put those four elements in, or create an empty array, and in this case, it will optimize it and it will call array.empty. Okay, so might not even allocate anything. So 2 points on that. A collection expression in and of itself doesn't have a type. And the compiler can look at the context of the code and decide the best way to instantiate a collection based on what it's going to be assigned to or used as. In this case, it's going to be assigned to an array. So this collection expression is going to mean we'll allocate an array and create an array. Right here, where I call write byte array, which if you look, this is a span. So it's one of these ref struct types for performance. So it's going to be on the stack. So it's going to put some things on the stack for me and just look at the span of bytes. And if I use a collection expression here, what the compiler is free to do is it can look at that and go, okay, this is going to be a span. So first it's going to create possibly an internal structure. And in this instance, it can look at the ref safety rules and say, you know what? It can do something even better. It knows that this is supposed to be a span of bytes, so it can do something internally, like say, I'm going to do a stack alloc. I'm going to say, like, I'll say var v equals, actually, I have to make it a span, I think. Span of byte, v equals stack alloc. And I'm going to have to remember the syntax for this. Byte of 3. And I'm going to initialize it to, going to have to make these bytes of 1, of 2, and byte of 3. There we go. Now, and then it will basically put that in this place here. So what that means, what the compiler can do is you write just an expression of the data that you want. I want an array of bytes or a span of bytes that's got the values 1, 2, and 3 for the 3 bytes. And the compiler looks at the context of how that collection is going to get used and say, all right, I can make it on the stack, so I'm going to stack allocate. It's not that big, so I'm definitely going to stack allocate, which gives you better performance. You don't have to remember to stack allocate, and it's going to get initialized correctly. And it will only do that if your usage of the type matches ref safety. So if I were to put this same expression like inside one of these methods and then return it, it couldn't be stack alloc because it would violate ref safety and it would be off the stack. Okay, so key point there is it's going to figure out the right syntax and figure out the best way to express your collection. The next one where I have a list, one of the other reasons we really like collection expressions is, if you notice, this syntax is different than what I had up here where I said this was going to be a new int something, and then I'm going to put things in it, right? I have to remember it's something different when it's a list. Well, I don't have to with collection expressions. I can just say, you know what? Just do the same thing here. We're going to make this a collection expression. I don't care what it is, let the compiler figure it out. Span of dates, I can do the same thing here. I don't have to just use literals. I can put any expression there. And once again, calling the right byte span, I can send that in a different way as well. Now, the final one I want to do is this new operator with the 2 dots that we call the splat operator. And this is where collection expressions, the compiler has to do a fair amount more work, but it also makes your life a lot easier. So what does this mean? The 2 dots means the next token that you see is going to be an expression that is itself a collection. So enumerate all that collection and place every one of those elements inside this more numbers collection. So this says take all of the contents of numbers 1, 2, and 3, followed by all of the contents of numbers 2, 4, 5, and 6, and then the single elements 7, 8, and 9. Okay, so you can construct a collection by enumerating, say, the results of a LINQ query, or putting together different collections any way you want, and the compiler figures out how to do it. Now, in something like this, the compiler also has a lot of freedom to optimize based on static analysis. So once again, what I mean by that, we have an array here. So the compiler knows that this is an array of 3 elements, and it knows that numbers 2 is an array of 3 elements. So it knows that more numbers is going to have 9 elements. So it has array of 3, okay, another array of 3, okay, and 3 individual elements. So it can do one allocation for storage of 9 elements. Now, if I were to add another splat here where I were to put in, say, my x4, which is a list, okay, now the compiler, a list in the code here as written, it's relatively simple. The compiler does know how many is in it. But if x4 were passed to some other methods where maybe new elements got added or something got removed, it would look at the length property, or the count property of the list and go, aha, it's 3 plus 1 plus whatever the count property has, then plus 2, and allocate that, and then put all that in. Okay, so, and all that is specified where the compiler is going to somehow figure out how big the storage is, if it can, allocate it, and then fill it in a second pass. If it cannot figure out how big it is, it will make a decent guess. Like if this was an IEnumerable event, which doesn't have a count property, well, then it's going to start enumerating and do things and figure out how big it is. And possibly use some temporaries. But it will write the most important, or it will write the most efficient code it can based on everything the compiler knows at compile time. Okay, so here, once again, it contains those 9 elements. Okay, so that's collection expressions. One of the big things that we really like. The next one, I'm going to slide over into SharpLab and talk about records. So if we take SharpLab, it is effectively an online decompiler. So I can type C# in it, and I can see if I want IL, or in this case, I want C#. So what I've done here is I've created your basic person class. So I've got some properties, first name, last name, age, and a date-only property for birthday. One of the other new keywords we've added is this required keyword. What that says is if you were to later say, and I'll have to write a class here. And I'm just going to write a method. And inside this, we're going to new up. And right now I'm going to get compiler errors. And you'll see it says I didn't initialize those required members. So we're just going to say new, and then I have to set first name, and I have to set last name. In order to get this to compile. Yeah, that should work. Oh, there's no target type for new. Sorry. Fine. We'll do it that way. Okay. I can optionally set age and birthday, but I don't have to. Now, what the compiler generates there is just a few extra bits of attributes that we keep track of. But what I want to show you is some things we added in C# 9 and 10. I can make this a record. Okay. And now, as soon as I make this a record, now I'm going to get some other code back here. In addition to what was already generated by making a class, by saying it's a record, what I now have is value-based equality. And the compiler generates a lot of methods to implement value-based equality, but do so in a way that's definitely going to be correct. So you can see we have these compiler-generated methods. So I have an override of toString that looks a little bit complicated. It's going to make a new string builder. It's going to say it's a person. I'm going to put an opening brace here. Then it's going to call this method called print members with the string builder, then append a space, then append that closing brace, and then return string builder.string. So what does print members do? Well, print members, this first bit just makes sure we don't have an infinite loop in our records pointing to other records pointing back kind of thing. And then what it says is I am going to write each of the properties in this type. Okay. Now notice that it's virtual. I'll get to why in a moment. Then it adds that we have a not equal property. So it returns left not equal to right. It's going to have an equal property, which checks each one and returns if any of these are null. If it's not null, it's right or left. It's going to have a get hash code. And let's see if I can. No. And get hash code is going to do a little bit of munging around with a few constants here and there and put some voodoo in place to get a decent hash code based on the kinds and the numbers of properties that I have. So I could use this person type as the key in a hash map and get a good distribution. We've got our override of equals. We've got a virtual override of equals. I'll get to why that's virtual in another minute. We have a compiler generated clone method. And then we have a copy constructor that's protected. All right, now why are some of these things, some of the clone methods is because I can do something like say, start with a person and then say person P2 equals P1 with, and change one or more of the properties. And that's going to call that clone, which returns a new person record, and it then going to set the new properties to the different values that I wanted. Now, the reason this is all virtual is if I were to add another record, and we'll say it's a student, and it derives from person. And for the moment here, I'm not going to, we'll just add one int property to it just to get it to generate a little bit more code. And we'll say it's its grade level. And we'll give that a get, and a set. All right, now, why is that in here? So what happens now, because I have a derived class, is if we scroll down and look at what's generated for student, we can see that now some of these are overridden. This equality contract says what type it is. So if I'm comparing a student and a person, they won't be equal because they're two different types. Now you can see that toString is an override, and when it calls print members is going to call the base member to print all the members of the person class, and then add the grade level properties on the derived class. Now our clone, see, is going to return a new student, which also is using the copy constructor, and that's going to chain to the base copy constructor, and then it's going to copy the derived pieces. What this does is this means we can create hierarchies of records, and the compiler generates all the right access methods, virtual and override, in order to update, make sure that the types behave the way you want. If I'm seeing if a derived type record and a base record are equal to each other, they never will be because they're different types. If I go to clone or use a with expression to copy a student, it's always going to give me a new student type, never a person type, even if I assign it to a person, right? And now if I remove like this extra property, I think a compiler does a little bit simpler code. And in the derived class, it just calls base.print members. Now I'm going to make a couple more changes. A record doesn't have to be a class. I can't state it is. I can also say it's a struct. Now, when I say a record is a struct, we already have some form of value-based equality going on here, but the record generates some slightly better versions of it. Okay. Its version of equality is going to be better than the version in just a regular struct, which uses reflection to see what properties are there and figure it out. So this is going to be faster than a regular struct. We still have the same get hash code, and we still have equality comparer. Now note that because it's a struct, nothing here is virtual. We don't have overrides because you can't build a hierarchy of it. And then finally, I can say, you know what, this is going to be a read-only record struct. Now I'm going to have to change these to init only setters, because then they can only be set at initialization and not set later. And now a few other things get a little simpler inside here, in that we know the values aren't going to change. And if I were to write any other method in here, I couldn't write a method inside this person struct to say, public void get older. And I could say age equals age plus 1. And that's not going to compile because I can't set it. I'll get the same thing if I do age plus plus, but I think I get a different compiler error. Okay, but so what's happening here is, by saying it's a record, what we're doing is we're saying to the compiler, please write roughly a page and a half of code that I know you've debugged and the compiler team has debugged, and we don't have to worry about whether it's correct or not correct. It's going to be the right thing. So that gives us a lot more structure there. So it's one of the other features that we're really excited about seeing people use. And I added a few other smaller features that were related to records, like that required modifier on properties, the init setters as opposed to get and set, adding read only for structs, and so on. And the last one we really like is working with pattern matching. So there's a few different things that we can do with pattern matching, where with patterns, I can write logic based on the structure or the values of objects. So I've got a couple things here where I can look at, like, what is the state of water? Well, if it's greater than 212 Fahrenheit, it's going to be a gas. If it's greater than 32 and less than 212, well, it's going to be a liquid. If it's exactly 32, it's in a transition state. Less than 312, it's solid. And at 212, it's a solid gas transition. Now, some of the reasons we like pattern matching is because you can put a lot of a lot of different kinds of logic in here and look at different properties of things. And patterns help us. If I remove one of these, I now get a warning that says that it doesn't handle all possible values. Because since this is less than, rather than say less than or equal here, I don't handle all values. And anytime you don't handle every value in a switch, well, you're going to end up with the pattern matching switch saying, there's some way to fall through this and never hit any of the arms. So you should probably update that. We can do the same thing in terms of like a slightly different one. We can rearrange it, and we can use a discard here to say this matches basically anything. Okay. I can also do some things where I can write it as a switch statement that takes more than one input. So I could write, say, our OR method with two different inputs. Okay. And instead of this, which is, well, it's obviously correct because we have it, but I'm going to make a tuple of left comma right and switch on that. And then if it is, say, false, false, well, that's going to be returning false. And I'm going to write them all out at the moment, even though Copilot's trying to help me write the more efficient code immediately. If it's true, false, well, we know it's going to be true. If it is false, true, we also know it's going to be true. Why am I getting an error there? What are you doing? Oh, I did my semicolon there. Why are you? No. Left, right. Bang. There. It should be this. Yeah, it should be good. Yeah. Oh. Becomes this. Switch. I do not want my lambda there. Sorry. All right. And then true, true. It also returns true. Now, once I've got a full table, I can kind of, I can simplify stuff. Well, if I notice that, both of these are, anytime the first one's true, I really don't care what the second one is. It's going to be true. Right. And now you can see the last one, I'm getting an error saying, you're never going to hit this because you already covered that case before. Oh, okay, that's fine. So I don't care. So then I can do the same thing here. Yeah, that's fine. Okay. And as I've written it, I can now put these in the opposite order. All right. But if I keep this one first, I can then go back to what Copilot was trying to tell me, and I can simplify it further and say, for anything else, it's fine. Okay. A slightly more interesting one is if I do XOR, well, then this, if I were to say true, true, this one is false. And then everything else is true, right? So you can combine this in all kinds of different ways. And one of my larger tutorials, we did a really long, interesting one where what we're doing is we're trying to decide is, all right, if I were to take, say, going over one of our bridges and saying, we really want to do some peak pricing here. So if you're in a car, we're going to change the toll based on how many people are in it. If it's a bus, well, it depends on how full it is. If it's, taxis, okay, that's some bit better. If it's trucks, well, during peak times, we really don't want truck traffic. So we're going to set eventually, how much am I going to have to pay? All right. So I'm going to say that if I want to say, if I'm going inbound during rush hour, I pay more than if I'm going inbound at off times. And if I'm going outbound at the evening rush, it pays more. Now, if I were to write this in if then else logic, I end up with something like this that is about 30 lines of code. Okay. And what it's saying is, all right, so if it's Saturday or Sunday, I'm on the weekend, normal price. Otherwise, well, let's figure out what hour it is. It's before 6 in the morning, you get a 25% discount. If it's, well, at least 6, but less than 10, well, now if it's inbound, I'm going to double the cost. If it's outbound, normal price. And now if it's, well, less than 4 in the afternoon, oh, but wait, but it has to be after 10 and less than 4, now it's a 50% premium. And if it's after, or it's before 8, but after 4, then going into the city is regular price, going out is double. And if it's after 8 at night, then 25% discount again. Now let's write this with a few different pattern matching methods. So if I start with this and say, what week is it a weekday? Saturday and Sunday? No, everything else is true. Okay. Now I'm going to define an enum for time bands. And I'm going to say, which time band are you in? Well, if it's before 6 or after 7, it's overnight. If it's before 10 and didn't match the first one, it's morning rush. If it's before 4 but didn't match these, it's daytime. Otherwise, it's going to be evening rush. And now I can write a little bit more of a switch statement to say, all right, so depending on if it's a weekday, what time band you're in, and if you're going in or out, here's your premium prices. Okay. And I can simplify those by shrinking down which ones and using a few more discards to end up with just this. Anytime it's overnight, 25% discount. Anytime during the middle of the day, not rush hour, it's 1.5 times the normal price. And if it's morning rush and you're going into town, well, it's double. If it's evening rush and you're going home, it's double. And why I like this sample in terms of looking for things like pattern matching is if you take the original one, okay, that's all classic 1.0 C# stuff. If then else, bounded around, it is almost exactly 50 lines of code. Okay, I could shrink it by getting rid of those curly braces and end up getting errors later when the junior programmer adds another line of code after one of them. But the final version is all of 5 or 6 lines of code, but it's also very clear what it means. So when I look at that bit of code, I've got, yep, this is what it means. So what I recommend to do is start to look at pattern matching as a way to write your logic when you see some of these, fireman's ladder, if then else, and in and out. And is there a way to look at that differently and come up with a simpler and more clear way to write what you're doing using patterns? All right. So that's pretty much all of the demo part. So there's a few bits of concepts I want to go over as we finish some of this, and then we can leave a few different space for questions and for where C# is going to go in the future. So if you're looking at this and you want to look at it, if you look at the fundamental section for C#, this is where I'm going to add a lot of things to keep growing that section in terms of what do we think everybody's going to be using almost every day. I showed about 3 of these examples, pattern matching. So it replaces this imperative branching, testing, and looking at things with some expressions that you test against to determine the flow of your logic. It's got a very rich vocabulary. We can even do list patterns now to see if a list contains a certain sequence of elements in a certain location. Supports a lot of different scenarios. I will be honest, when I started writing about pattern matching and starting to adopt it, I made myself the habit of every time I wrote code and I saw myself writing if then else or switch statements and so on, I would try to rewrite it using pattern matching and see if I liked it looking simpler. I probably found that in roughly 60 to 70% of the time, the pattern matching logic ended up being simpler and easier to test. Collection expressions. So that gives you the same syntax no matter what kind of a sequence you're working with, as long as it is a sequence. There are 2 or 3 things that we're going to add to collection expressions in that are planned for C# 13, which isn't out yet. So we hope these both get in. One of them is params collections. So if you have a method that takes, params int array or param string array, those can now users can now pass a collection expression to them. So that will simplify that. And related, we're going to allow params of different collection types. So you can have param span, params list, params IEnumerable. We hope both of those features get in. Reasonably confident. There's some edges on collection expressions and params we're still working through. But most importantly, that's the same syntax no matter what the kind of collection is. Primary constructors, which I didn't show, related to records, is you can define a primary constructor on a type. So I can refactor this relatively quickly. If we wanted to do this as a primary constructor, I could just say string first name, string last name, and just to save some typing. Yeah, well, okay, fine. You can do that. And Copilot helped me finish it. And now I don't need any of that. And that's my entire class definition. Now, where this is useful in places where you add a lot more code is if you have a type, and let's say it's one of your controllers that requires something through dependency injection, and it only works if that type is given to it. Primary constructor is a great way to express that. My constructor requires these fields to be set. Here, because of the way I had it before, I would probably write this one more like this and say those two have to come in and these two don't. And it would look something like that. So now those are required, the other two aren't. Okay, so it would look something like that. And the record modifier, as I said, a lot of compiler generated value semantics. So those are methods that are easy to get wrong if you're not thinking through all of the uses of your type. So instead, what we're going to say is, well, if you add the record modifier, the compiler is going to synthesize those methods for you. One thing I didn't demonstrate is if you write one of those methods yourself, the compiler won't try to replace it. It will use the one you wrote. So if you can do a better get hash code, hint, you probably can't. But if you could write it yourself. If you want the output to look different, you could write your own print members and it would display only the things that you wanted to or in the format that you wanted. If you wrote your own toString, same thing. It would not go through the normal mechanism of calling calling print members. And in a base record, you could even write a sealed toString, so derived records couldn't change it. The compiler looks at what you wrote and only adds what it needs to. So, and then for everyone here, I would say, incorporate these concepts into what you're using. Right? If it's something that's going to make your life simpler right now, go ahead and use it. Start using it right away. Consider replacing code as you're refactoring. Nice, but it's minimal impact. Adopt it as you make updates. Some of the newer features have positive performance impact. Span is one of the features that definitely can. Collection expressions can be faster than traditional collection initializers or other ways of initializing a collection. Depends on how much you'll actually see, depends on the use, and depends on your app. And if it doesn't really help you, then don't add it to your project. One of the other ones, I didn't show here, top level statements we think can make programs look and read simpler in many ways. Some people really don't like them. And there's no benefit to really like rip out your public static void main. It's already there. And so build your own subset of what is Everyday C# in your domain and with the kinds of apps that you're building. So different things to do. Look at .ms, get .NET 8, download .NET 8. It's faster, it's spiffier. It has all the new features. What's new in C#? If you replace that 12 at the end with 13, you'll see the preview features that we have at the moment. The GitHub project for Everyday C#, you can see discussions or get involved in what I think the table of contents will look like as I flesh it out in more different ways. The pattern matching tutorial I alluded to, there's a lot more code in that, is that final link there. And with that, I'll take any other questions and kind of walk through anything else C# related. Or turn it back over to Robert.
Okay, thanks, Bill. Anybody have any questions?
Hey, Robert, I have a question.
Okay, sure.
Bill, thank you so much for the
Mhm.
information. My question is that when we have like these new features we are trying to adopt that,
Mhm.
what kind of precautions that we have to take? I mean, is there any side effect or I
Right.
understand that it's fully tested, but yeah, go ahead.
Yeah, that's a good question. I mean, okay, so due diligence, I would obviously, run your normal suite of tests, right? In most of the cases, well, I'll pop this up. I do have, give me a new tab here. All right, and that's going to be close enough. If I go into our C# stuff, we do publish the breaking changes document. So if you do see anything else, we don't have any that have gone out for 13 yet. I'll add that as soon as we do. But if you look, this is what breaking changes we took somewhere from .NET 7 into .NET 8. So if you were upgrading and you recompile with the new compiler and set the language version, you could see these errors. So there's about 4 of these here. In general, we try to keep those really short, right? Like if you look at 11, I think had a few, about 5 or 6. I think we had a few more here, but they are pretty edge casey. And again, I would say with your product, you should definitely run a good suite of tests anytime you put in a new compiler. But that I think is probably where I would consider just due diligence. We do have a really high bar for this code doesn't, the new compiler does something different. When you're adding new language features, you are changing code. So once again, you should run your test suites. And if you think there's a performance impact, run any of the performance tests as well.
Okay, yeah.
Yep.
That was helpful. Thank you.
Yeah. And I would add that with any of the new language features, we try to, our goal is that a new language feature should be as fast or faster than what it is replacing, or generate code that is as fast or faster. And anything else?
Okay, no, I think that's it.
All
All right.
right.
Well, thank you, Bill. Really appreciate it. And yeah, great presentation.
All right. Thank you very much, Robert.